Alright, so we want to sketch this rational function and then answer some questions about it. So let's look at the function there. Let's go ahead and factor this. So to factor that numerator, we're going to pull out a 2x, and left behind is an x minus 2. In the denominator, let's see what we can pull out. Well, I can pull out an x, and I'm left with x squared minus 9. So notice I have an x and an x right there. So I'm going to get a whole when x is 0. Whole at x equals 0. Now, denominator x squared minus 9, that is a difference of squares. So, fully factored, I'm going to get 2 times x minus 2, which gives me a 0 at x equals 2, over x plus 3 times x minus 3. So I have vertical asymptotes at x equals plus or minus 3. And then finally, notice that the degree of the denominator is 3, and the degree of the numerator is 2. So I'm going to get my horizontal asymptote at y equals 0. So now let's piece all this together and sketch the graph. So 1, 2, 3, 4, 5, I don't know why I was counting those, but just putting in those asymptotes. Remember, I've got that horizontal asymptote as well. I had a 0 at x equals 2, and now I need to sketch in this function. So let's look to this area over here and figure out where I am located, above or below the x-axis there. So let's look at our factors. We need to try a point like positive 4. Well, that's going to make that positive, it's going to make that positive, and that positive. So all of those are positive, so I'm definitely positive over here, like that, which means I then have to be down something like that, and like that as well. And all my tails are going in opposite directions from each other because the multiplicity of my factors in the denominator are both 1. So now let's answer some questions, but remember we have a whole when x is 0, so we have a whole right there. So, limit as x goes to 0 of f of x. Well, we can't really get that from our graph. We need to look at our function. Let's substitute in 0, see what we get. So we're going to get 2 times negative 2 over 3 times negative 3. I'm just using that factored equation up there, which is going to simplify to 4 over 9, which does not simplify any further, so I get 4/9 right there. For 25, the second number 25, as x goes to 2, so we know that the function is heading to that 0 right there, so the limit there is going to be 0. As x goes to 3 from the left, I'm going down to negative infinity. There you go. As x goes to 3 from the right, I'm going up towards positive infinity. As x goes to 3, since my tails disagree, I'm undefined. It does not exist there. As x goes to negative 3 from the left side, I'm going down to negative infinity. As x goes to negative 3 from the right, I'm going up to positive infinity. And just like the last one, since those tails are heading towards opposite infinities, our limit does not exist there, and we are done.